So this first question that we have here is asking us to build a frequency table showing frequency, relative frequency, and cumulative relative frequency. And then we need to create a pivot table to show the data. And then we need to build a histogram. So this first step here is to build this frequency table, right? So we have some information about customers. Our numbers are between 0 and 4. So let's say, customers that showed up in an hour, right? So 2 customers, 1 customer, 3 customers. If we want to create this frequency table, we would have frequency in our next column, right? And then how could we show the frequency without having to go through and count all of these? What can we use in a Excel formula to figure out the frequency? So we have a few different options here. We do have a frequency. So,
sorry, I was trying to put some of those numbers in real quick so I can follow along.
Oh, okay. So when we are using the frequency function, the one thing that we need to be careful with is we first need to select the array of cells here that we want the data to come back to. And then we can come up here to the top and we can type in frequency. The first piece of information is our data array. So we can select all of column A. And then the next piece is bins array. So that's when we're just going to select this 0 through 4 right here. Close our parentheses, and we hit enter, and then we have our frequencies there. Now, let's say you forgot that frequency existed, right? There's another way that we could have done this. We could have used our COUNTIF function, right? So COUNTIF is asking for a range, which is once again all of our data, and then a criteria. So then we would just select one singular criteria here. And we can see that for 0 customers, there's 6 of those, right? So that's the same that we get up here when we use our frequency. So there's 2 different approaches that we could take in that situation. So our next piece here is relative frequency. What is relative frequency? What are we trying to figure out here? So relative frequency is going to tell us like percentages, right? So X% falls within this bin of 0 customers, or X% is comes back as 1 customer. So the way that we'll do this is we want to figure out our total first. So we need to add up our frequencies, right? So we can add up our frequencies using the sum function. So sum all of our frequencies, and we can see that there's 35 of those. Another way that we could have done that is gone over to our data, selected our data, and then at the bottom of your Excel screen that I don't think is showing up. Okay, so at the bottom of your Excel screen, there's going to be something that says count. And that's going to show you 35, which will also be the sum of all of your frequencies. Now, when we are figuring out our relative frequency, we want to find, for 0 customers, our relative frequency. We go equals, and we select that 6 divided by this 35, this sum of all of our frequencies, right? We hit enter, and we see that we get 0.1714, right? We can clean this up a bit by decreasing the number of decimals here. So we get 0.1714. If I drag this down, we get some errors that pop up, right? So what I need to do when I'm creating this function is I need to freeze this D8 cell. I need to say that even when I pull this function down into other cells, D8, that sum of our frequencies, needs to remain the same. So now when I do that, it's now going to here take D3 divided by D8, D4 divided by D8, right? So the way that we can freeze a cell is by putting dollar signs in front of both the column and the row information, right? So $D, $8. A quick shortcut there, right? If we just had D8, is you could hit F4 and it automatically does that for you. Now, you see that you can just cycle through with F4 and it will freeze either the column or the row, depending on whatever that dollar sign is in front of, right? So you could do that as well. But here we want that cell to remain constant. So we want the dollar signs in front of each. Now, we need to figure out cumulative relative frequency. A few different ways that we can go about this. Let's first find cumulative frequency. Cumulative frequency is just the frequency built up on top of itself, right? So for the first cell, for the first bin, it's just going to be this 6. It's just that first group. But then we want to add in to this 6 this 10 that we had under the 1 customer group. And then we get 16. Now, we could continue just going down the list and putting 16 plus this other 10. And we could keep going. Or we can just drag down, right? We get the little black cross in the lower right corner of the cell. We drag down, and that will find your cumulative frequencies for you. And you'll notice your cumulative frequency here as your last group is equal to your n, right? The total number of data points that we had. Now, when we are looking for cumulative relative frequency, it's a similar approach as to what we did with our relative frequency. But in this case, rather than just taking our frequency divided by n, we now take our cumulative frequency divided by n. So we'll take this 6 divided by our 35, and we need to remember to freeze that D8 again. We hit enter. Let's clean these up again. And then we can just pull down our formula. And once again, it's taking each cumulative frequencies and dividing it by 35. And you'll notice your cumulative frequency will end up with 1, because this final cumulative relative frequency is 35 divided by 35. So we've built this frequency table. Now, part B is asking us to create a pivot table to show the frequency of the data. So we come up here, we hit Insert, we want a pivot table. It wants to know where all of our data is, right? So we select column A, and we hit OK. Now over here in our pivot table fields, we have our customers, right? So let's pull this down into rows, and there we see the different groups, right? The 1 or the 0, 1, 2, 3, and 4. We need values though, right, for the frequencies. So we pull our customers once again into values. And we get 0, 10, 20, 15, and 16. Well, these numbers don't match up with these frequency numbers over here. And that's an issue, right? The issue is because we have our values showing up as the sum. So we need to come down here into values and select our value field settings. And instead of sum, we're going to want the count. So when we find the count of customers, we then hit OK. And now we can see that our frequencies here match up with the frequencies that we had originally. So we're going to be creating more pivot tables throughout the review. But pivot tables can be a great way to quickly find all of this information. Right now, the last piece here is to build a histogram. A histogram is just a different form of a bar graph, right? So what we'll do is we'll come up here to Insert, say that we want a bar graph, or let's go, okay, so I need to select, go Recommended Charts, and we have this bar graph here, right? We'll hit OK. There's one thing that we need to do to turn this into a histogram. A histogram is not going to have these gaps. So what we can do, okay, so we come over here, we right click, and we hit Format Data Series. Now, we see over on the far right here, gap width. We want this gap width to go all the way down to 0. And that's going to turn this into a histogram, right? Because if there's just gaps, that's not what we want. We want no gaps. We want to show that there's no possibility of any data being between 0 and 1. So we get rid of those gaps in our histogram. So, any questions here over number 1? Okay. Again, if you guys have questions, feel free just to unmute your mics, or you can type them over in the chat. I have that up as well. So, let's move on to question number 2. We are going to use a pivot table to create a contingency table here. So we have the gender of pet owners and the pet that they have, right? So we want a pivot table that's going to look somewhat similar to this here. Let's make a pivot table here with this information. So once again, we need to go up to Insert, and we need to hit the pivot table, and it's asking for our data. So our data is here in columns A and B. Where do we want it? This seems like a good spot right here. We hit OK. Oh, okay. So I already had that there. So we want it right there, and it'll create this pivot table for us. Now, we have two different variables, right? We have gender and we have what pet they have. So we can put the gender under our rows and the pet under our columns, and then it'll look kind of similar to what we have up here, right? But we need values. So what we want to do is we want to take our pets here, and you can see that our values are under count, right? This is important, once again, because we want to make sure that it's the count of how many dog owners that are female, how many fish owners that are male, right? Make sure that you're always using the count when you are building a pivot table like this. So again, we just dragged our variables into the columns and the rows, and then our values as well. And then we made this contingency table, right? So it's a quicker way to be able to build this rather than trying to go through and counting how many fit each group, right? So looking at this, we can say, okay, there are 5 fish owners that are male. There are 4 cat owners that are female. And so here we only had like 35 pieces of data, right? We just had these 35 here. If you guys are dealing with actual survey numbers, that number could be in the thousands, right? So a way to make sure that we aren't spending way too much time building a table is to use something like a pivot table. So if we take a look at question number 3 now. Question number 3 is asking us to calculate the mean, median, and mode of the sample data, and then calculate the range, variance, and standard deviation of the sample data. So whenever we look at a sample, one of the most important things to know is how many pieces of data are in that sample, right? So that's our n. Our little n is our sample size. There's a few ways that we could do this here, right? We could just go through and count the number of data points that we have, right? So we see that it ends in row 51. So we know since it starts in row 2 that there's going to be 50, right? But there's a function that we can use. If we use the count function and we select our data, right? And so a keyboard shortcut here is we select our starting point of the data, and if we go Shift Control down arrow, that's going to select everything all the way down to the last data point. So then we can hit enter, and we see that our n is 50. So we have all of our data points there. We have our 50 data points. Now we can move on to figuring out our mean, median, and mode. So the mean is the average, right? So there's a few different ways to calculate the average. We could take the sum of all of our data and divide it by our n, right? So the sum of our data divided by our sample size gives us our mean. Another way that we can do this is we have this Excel function for average. So we go equals average. We select our data once again, and we get the same number as our mean, right? So either way, we are finding our average. So we could sum up all of our data, divide it by n, or just use the average function that Excel gives us. Now the median, the easiest way to do this is the median function. So we go equals median, and we want to select all of our data again. And we see that our median is 11. Now mode is a little tricky here. Mode is which number appears most often, right? So sometimes you're going to have one mode. Other times in data, you could have multiple. So if we just assume that there's one single mode here, and we use the mode.sngl function for just a singular mode, select all of our data, we come back with an answer, right? Mode of 11. However, that's not correct because there's more than one mode here. So it's not going to tell you that there's more than one unless you use the mode.mult function. Now, mode.mult, just like what happened earlier when we were using the frequency function, we need to select a group of cells for our mode to come back to us in, right? So we select this group of cells here. We come up to our function bar at the top, and we can type in mode.mult and then select all of our data. And if we select all of our data and hit enter, we then see that we have modes of 11, 19, and 16, meaning these three numbers showed up in equal amount of times. Right? So 11 is still part of it, but mode.single for a singular mode did not return these extra two modes that you actually had. Now, if you're looking at data, and let's say we have thousands of data points again, and we get a mode of 11, 19, and 16. We know that those show up the most often. There's other information that we're going to want than just that, right? We're going to want to know how often do they show up, right? Because if they just show up twice, that's not really going to help us at all, right? That doesn't really tell us much about the data. But if they each show up 20 times, then all of a sudden we're a little bit more interested in these modes. So the easiest way to do this is once again creating a pivot table. So we'll come up here, we'll find our pivot table, we'll say our data's in A, hit OK, and then we have our number of used cars sold as our variable, right? So we can toss that into rows, we can toss that into values. Once again, it automatically went with the sum of the number of used cars sold. We want to change this again to our count. And then we can come in here and we can take a look at our information. So we can see that 11 shows up 5 times, 16 shows up 5 times, and 19 shows up 5 times. Right? So that lets us know how common these modes really are. So sometimes just getting these modes as an answer doesn't truly tell us about the overall data that we have. Now, the other part of this was calculating the range, variance, and standard deviation. Your range is just your biggest number minus your smallest number, right? So what I would recommend doing is finding your max and your min of your data. So you can go equals max, select your data, and we see that the largest number that we have is 19. We can go equals min, select our data, and the smallest number that we have is 1. So our range is going to be our max of 19 minus our min of 1, right? Maximum minus the minimum values. And we see that our range is 18. Now variance tells us about the spread of our data, right? So there's a function here. We have two different options. We have var.p and var.s. The difference is var.p is dealing with a population. var.s is dealing with a sample. Because the formulas to find your variance is different depending on whether you have population data or sample data. Now, this question specifies that this is sample data. So we're going to go with var.s. And then they just want all of our information here, all of our data points. So we can select our data points, and we can see that our variance comes back at that 31.02. Standard deviation is simply the square root of your variance. So, in order to do that, we do our square root function, and we can come up here and we can select our variance, and we can find our standard deviation of 5.57. So these are all pieces of information that will be helpful for giving you information about the data as a whole, right? When we have a large group of data here, figuring out what the average is, finding what the median is, figuring out the range, the standard deviation, all of these pieces will help explain how that data is. So we find all of these values here, and then you'll learn in future chapters, right, what we do with the standard deviation, what we do with the mean. When you guys get into more dealing with z-scores, you're going to be using means and standard deviations a lot more. So this is just kind of step one into that. So if we take a look here, we have a Bayes theorem problem. So Bayes theorem is when we draw that tree and then we have to make a chart from it, right? So the information that we're told is that the percentage of adult internet users who use Facebook has increased over time. Of adult internet users age 18 to 49, 81% use Facebook. Of adult internet users 50 and older, 54% of them use Facebook. Assume that 52% of adult internet users are age 18 to 49. So there's a lot of numbers thrown at us right there, right? The first thing that we want to do is think about how do we initially split up this population of people, right? So the first way that we're going to split these people up is between their ages. So we have 18 to 49 and we have 50 plus, right? That's the first way that we split up our population here. So 50 plus we were told, or I'm sorry, we were told that 18 to 49 was 52% of internet users. So that would mean that 50 plus is the other 48%, right? Because each group in a tree like this has to add up to 100%. Now we want to split off in both of these. And we can say, okay, these people use Facebook, these people do not use Facebook. So then when we go through this, 18 to 49, the percentage of them that use Facebook, we were told was 81%, which means the percentage of them that do not use Facebook is going to be that other 19%, right? Because again, these two have to add up to 100. Now in our older age group here, the 50 plus group, the percentage of them that do use Facebook, we were told was 54%, which means that the percentage of them that do not use Facebook will be 46%. So we've now created our tree, but we still have a few extra steps that we need to do here. So we need to multiply out, meaning we need to take this 0.52 and multiply it by 0.81 and 0.19. So we'll do that first. So 0.52 times 0.81 and 0.52 times 0.19, right? We're finding the joint probabilities here. If we continue down here, we take the 0.48 and multiply it by 0.54. And then we take the 0.48 times the 0.46. So we have a few values here that will be helpful to us. However, there's another step before we can even think about solving our problem here. We need to create this now into a table. So if we create our table here, we can go with ages on the rows and Facebook and no Facebook as our columns. And we always want totals when we are creating a table like this, right? So our values here are going to be coming from what we found when we multiplied out, when we found our joint probabilities. So in this cell, Facebook and 18 to 49, we see that it's this 0.4212. So we toss that into that cell. Now 18 to 49 and not Facebook, so 18 to 49 and not Facebook gives us this 0.0988. Then we can fill out the 50 plus group. So 50 plus and Facebook is 0.2592. And 50 plus and not Facebook is 0.2208. So we have all of our joint probabilities thrown into this table. We then need to add up our rows and our columns. So if we add up our rows, you'll notice we get some familiar numbers here, right? For our rows, we get the 52% and we get the 48% that we saw right here, right? Because this first row is the total of 18 to 49 year olds, which we knew from the start was 52%. Then, if we add up our columns, here we're going to get some numbers that we might not recognize, right? we get this 0.6804 and 0.3196 for our columns for Facebook and not Facebook. And then you'll notice the grand total here is 1. It has to be 1 because it's the entire group of this population. Right? So your grand total will be 1. Now we can start thinking about our two different problems here. So problem A is asking for the probability, right? They say, given that an adult internet user uses Facebook, what's the probability that they are age 18 to 49? So it's given to you backwards, right? The way that we would write this out is the probability of 18 to 49 given that they use Facebook. So the way that I recommend looking at a given here is whatever is after this given symbol, this straight line, that's going to be your denominator. So our given is Facebook. So our denominator will be this 0.68 because that's our total for Facebook. And we're only looking at this group for Facebook because that's our given. So our probability that they are 18 to 49 given that they use Facebook, what we'll do to solve that is we will take this 0.4212 divided by our total for Facebook. That probability that we get is this 0.619, right? So there's a 61.9% chance that they are age 18 to 49 given that they use Facebook. Now, the next part, given that someone is 50 or older, what's the probability that they use Facebook? So we're kind of just flipping around our two variables here, right? So the probability that someone uses Facebook given that they're 50 or older. Well, our given is 50 plus, so that becomes our denominator. And we're only looking at that group of data. So to find this value, we'll take the 50 plus and Facebook of the 0.2592, and we divide it by the total amount of that 50 plus, that 0.48. And we get our answer of 0.54. So, when you are working on a Bayes' theorem problem and you're finding your joint probabilities, remember step 1 is to build a tree. You build a tree, you multiply out to find these joint probabilities. Then you create a table, and then you can use that table to then answer your questions. So a couple more problems here. We need to figure out if this is a binomial problem or if this is a Poisson problem, right? So before we dive into the specifics of this individual problem, a few ways to figure that out. Binomial has two options, right? It's a yes or no situation, a success or failure. That's going to be our giveaway for binomial. Poisson means that your mean, your average that they give you, is in terms of time. So if we think of it as customers per hour, sales per day. That's going to tell us that it's going to lean more towards a Poisson problem, right? So in this exact example, we're told that past data for Southwest Airlines shows that flights arrive on time 80% of the time. And we need to figure out the probability that 14 of the 15 flights arrive on time today, and then the probability that at least 10 of the 15 flights arrive on time. So when we take a look at this problem here, flights either arrive on time or they do not arrive on time, right? It's a success or failure. Even though they throw the word time in there a bunch, we were not given a mean in terms of time. We didn't see that, it said Southwest airline flights are typically, 20 per hour or anything like that. Here we're just told either they arrive on time or they do not arrive on time. So that's what is going to tell us this is a binomial problem. And when you are dealing with a binomial problem, we have three pieces that we need to think about: our x, our n, and our p. When we have those three pieces, we can then toss it into the binomial function and it'll find our probabilities for us. So let's talk about our n and our p first. So our n is our sample size, right? So how many flights are there today? Well, in part A, it says what's the probability that 14 of the 15 flights today arrive on time? So our n is just that 15. That's our total number of flights. Our p is our probability, right? What's the probability of flights arriving on time? Well, we're told that past data shows that flights arrive on time 80% of the time. So your p will be 0.8. Our x is the successes, right? What are we trying to find the probability of? So we're trying to find the probability that at exactly 14 of these flights today arrive on time. So our x becomes this 14. So what we can then do is we can then use our binomial formula. So our binomial formula is binom.dist. And then it's going to ask for 4 pieces of information. The first one is our x. So we can select that 14. Our next one is our trials, that's our n. And then our probability. And then it's asking us, is this cumulative or not? So if we come back with true, what this is going to do is figure out the probability, the cumulative probability of 0 flights all the way up to 14 flights arriving on time. What we're looking for is exactly 14 flights. So we'll type in false, saying it's not cumulative. We hit enter, and we can see that the probability of exactly 14 flights arriving on time today is 0.1319. Now, if we did this for part B, our n still is that 15, and our p is still the 0.8. Our x is where things get a little tricky, because part B says what's the probability that at least 10 of the 15 flights today arrive on time. So we're trying to figure out at least 10. Now, there's not one easy way to figure out at least 10. What we are going to need to figure out is the probability of 9 or less. And then once we have that, then we can figure out the probability of at least 10. So, when we are figuring out the probability of 9 or fewer flights arriving on time today, what we can do is we can use our binomial function again. Our number of successes is 9. Our number of trials is our 15. Probability is 0.8. And this is where we put true instead of false like we did last time. Because we want to know the probability of 0 to 9. And so when we put in true, it's going to add up all of those probabilities for us. And we see that the probability of 9 or fewer flights arriving on time today is 0.06. Now, when we try to find the at least 10, like what this problem is asking for, what we need to do is we need to take 1 minus this number that we just found. Because all of your probabilities have to add up to 1. Right? So whenever you have to find something that says like at least 10 or 10 or more, the way that you're going to want to do this is to find your 9 or less first. Because let's say we had 500 flights, right? And I want to know the probability that at least 2 show up on time. You could go through and find the individual probabilities for 2, 3, 4, 5, 6, 7, all the way up to 500. That's going to take a long time, right? You could also find the cumulative probability of 0 and 1, and then just subtract that from 1. So that's what we're doing here. We found the probability that is the opposite of what we're looking for, and we subtract it from 1 to find this 0.3 or 0.9389 that we need. Now, our next part here is once again trying to figure out if it's binomial or Poisson. We're told that the average number of customers to come in the store in an hour is 20. So I think I sort of gave this away a little bit earlier, right? But our mean is given to us as 20 per hour, right? And whenever our mean is given in terms of time like this, that's telling us that we are dealing with a Poisson problem. So when you are dealing with a Poisson problem, you need 2 different pieces. You need your x and you need your mean. And those are the 2 pieces that you'll need in order to find your probabilities here. So part A is asking for the probability of exactly 16 customers arriving in 1 hour. So your x is your 16, because that's your number of customers. Your mean is where we need to be careful, because your mean needs to match up with the correct time units, right? So we were given 20 per hour. Here, we're trying to figure out the probability of exactly 16 customers in an hour. So we're good here. Our mean can stay at 20. We'll see in the next part when we have to change it. So we can now use that information and use our Poisson function. So we go Poisson.dist and it's going to ask for three things. It's going to ask for your x, so we'll select that 16. It's going to ask for your mean, so we select the 20. And then it's going to say, is this cumulative or not? Right? So once again, here we are looking for exactly 16, which this means it's not cumulative. If we were looking for 16 or fewer, then we would say that it is cumulative. But whenever you're looking for the probability of an exact amount, then we know that we have to put false. So that comes out to be 0.06 as our probability here that exactly 16 customers arrive in an hour. Now, part B, once again, we need to find our x and our mean. This part is saying what's the probability of exactly 8 customers arriving in 10 minutes. So our x, that's our 8. Right? That's a simple one to fill in here. Our mean is a little bit more confusing. So we were initially given a mean of 20 per hour. We need to put this mean in terms of per 10 minutes. So what I would recommend is first figuring out what is your mean per minute. So we can take this 20, divide it by 60 for 60 minutes in an hour, and we can see that per minute we get 0.33 customers. Well, per 10 minutes means that we just need to take that per minute amount and multiply it by 10. So now our mean that we get is just this 3.33. So on average, we get 3.33 customers in our store in 10 minutes. Once we do that math, the problem is then the same kind of steps that we just did in part A. We use our Poisson function. We select our x. We select our mean. And then it's asking if it's cumulative again. When we're told that we're looking for exactly 8 customers, we say it's not cumulative. So we put false, hit enter, and we can find our probability there.